Here we have a problem on finding derivative. That is, we have to find the derivative of this function with respect to x. Okay, here when I look at the function over here, so two terms are multiplied over here, and both the terms contain variable. So whenever I want to find derivative of a product of two terms where both the terms contain variable, I have to use the product rule. Okay, so what is product rule? Okay, let's consider a product u times v and assume both u and v are variables, and I want to find derivative of this product u and v. So for that, what I need to do is I have to keep the first term u as it is and get the derivative of the second term, then it will become v prime positive. Now I have to get the derivative of the first term u, then it will become u prime. I have to keep the second term v as it is. So this is product rule. So usually we use product rule to get derivative of a function. So where two terms are multiplied and both the terms contain variable. Okay, so in our function, two terms are multiplied and both the terms contain variable x. Okay, now let's find derivative of this function with respect to x. Here we have y. When I find derivative of this y with respect to x, it will be dy over dx. Okay, so here we can consider the first term 2 to the x power as u and the second term ln x as v. Okay, according to the product rule, first I have to keep the first term 2 to the x power as it is and get the derivative of the second term ln x. So that can be written as ln x prime positive. Now I have to get the derivative of the first term 2 to the x power and I have to keep the first term ln x as it is. Okay, now we have 2 to the x power. When I find derivative of this ln x with respect to x is just 1 over x positive. And so here we have to get the derivative of 2 to the x power. Here we have a constant at the base, constant 2 at the base and variable at the exponent. Okay, let's consider a structure a to the x power where a is a constant. So here we have a term which contains a constant a at the base and variable x at the exponent. I want to find derivative of this stuff with respect to x. So what should I do? The formula for this one is a to the x power times ln a. So this is a rule we have to follow to get derivative of a stuff where we have a constant at the base and variable at the exponent. Instead of the constant a, what if I have some other constant? So we have to follow the same rule, but we have to replace the constant a by the given constant. In our problem, instead of a, we have 2. So on the right side, wherever we find a, it has to be replaced by 2 to get the derivative of this 2 to the x power. So the derivative of this 2 to the x power with respect to x is 2 to the x power times ln 2. I just wrote the same stuff over here, but instead of a, I've taken 2 because here we have the constant 2 at the base times ln x. Okay, so in our next step, what we can do is we can factor 2 to the x power out because both the terms contain 2 to the x power. So we can factor 2 to the x power out. If I factor 2 to the x power out, then I'll be getting 1 over x left in the first term positive. In the second term, I have ln 2 times ln x. Okay, here now we have to add this fraction and this stuff. So when just assume this is an integer. So here I have an addition of a fraction and an integer. Whenever I want to add a fraction and an integer, so what I need to do is I have to multiply the integer part by the denominator of the fraction. So once I'm done with this multiplication, I can take this x as a common denominator. So 1 positive. Now I multiply this stuff by the denominator x, then I'll be getting x times ln 2 times ln x. So once I'm done with this multiplication, I can take this x as a common denominator. So the next step, what we can do is, so we can write the answer the other way. There is 2 to the x power, and this denominator x can be taken along with this 2x. Then you'll be getting 2 to the x power over x times 1 positive x times ln 2 times ln x. So this is the derivative of the given function with respect to x.